Hi, my dear students. Good day to one and all. This is Girish Ramdas, your science activity teacher. Some of the most Googled questions in the English speaking world is the one that kids are famous for asking and grown-ups are notorious for avoiding. They are, why the sky is blue while the cloud isn't? Why is the sun yellow? And why does it turn reddish, orange during sunrise and sunset? These questions might look difficult to answer at first. However, the science behind them is not difficult at all. Have you wondered why the sky is blue but the clouds are white? Why the sun appears red at sunrise or sunset? Why danger signal lights are always red in color? Any idea? Is it due to reflection of light, refraction of light, or dispersion of light? The answer is none of these. It's due to a completely different phenomenon known as scattering of light. And that's going to be the topic of this video lesson. I'm going to make the concept of scattering light really easy for you. First, let's understand what is scattering of light. I'm using my mobile torch as a resource for this. If I switch this torch, if I switch the torch, can you see the beam of light? I don't think so, because the light is invisible. But when I place my hand, or if you place a screen, then we can see the light, because we are seeing the reflection of the light by the hand or by the screen. Now, let's imagine this room is filled with dust. Then you can clearly see the beam of light. Why is that? Because the large number of dust particles are scattering the light, so we can see the beam of light. As we discussed, light is scattered by dust, that means larger particles. But light can be scattered by other tiny particles as well. Now, let's think about the question, the famous question, why the sky is blue? It's because of three things: the light from the sun, particles in the atmosphere, and the fact that we are all humans. We will discuss that last part by the end of this video. So, let's talk about the light from the sun and particles in the atmosphere.
There are two things that play an important role in giving a color to the sky. One is the atmosphere of the earth and the other is the sunlight, of course. So we need to know more about these two first. The white light coming from the sun is a mixture of 7 primary colors, and each colored light has a corresponding frequency and wavelength associated with it. The violet colored light has the shortest wavelength of all, while the red one has the largest. And what forms the Earth's atmosphere? The Earth's atmosphere is mainly composed of gases, dust particles, water droplets, and water vapor. Among the gases, nitrogen is present in the abundant quantity at around 78%. It is followed by oxygen, which is approximately 21%, and the remaining is filled with the likes of argon, carbon dioxide, and other gases. When sunlight strikes these molecules, it gets scattered. Scattering is a process in which the light is absorbed by the atoms and re-emitted back in various directions. However, not all the light is scattered equally. The amount of light that will be scattered is given by Rayleigh's law of scattering. It says that the amount of scattered light or the intensity of the scattered light is inversely proportional to the fourth power of the wavelength of a wave. I is inversely proportional to lambda to the fourth power. If the value of lambda increases, then intensity will be lower. Now you want to tell me among the 7 colors of sunlight, which one will be scattered the most? Yes, the light of the color corresponding to the smallest wavelength will be scattered the most. So blue, indigo and violet light will be scattered most by these molecules of air. And when this light travels to our eyes, the sky appears blue to us. But wait, the violet light has the smallest wavelength. Then why doesn't the sky appear violet or even indigo for that matter? There comes the human part. The following graph tells us how much of a particular wavelength is emitted by the sun. Observe the graph well. As you can see, the sun emits more blue and light bluish light compared to the violet light. Hence, more blue light is scattered by air molecules, resulting in the blue color of the sky. And another reason why we cannot see violet light is because of our eyes are more sensitive to blue light than to violet light. Do dust particles and water droplets also scatter light? Yes, they do. They scatter light as well. However, their size is comparatively much bigger than the size of the light waves, and hence they scatter all the colors of light in equal amounts. So, the light, the white light which is entering the cloud or the dust particles emerges out as white light again. Hence, the clouds appear white.
What do you think the color of the sky would be if there was no atmosphere? Yes, that's right. Black. Just like it appears to an astronaut. Because if there are no particles to scatter the light, the sky would appear black to us. The sun would still appear white. So, the blue color of the sky is an optical illusion. It is due to the preferential scattering of light by the air molecules. Now, we see the reason behind the blue sky. We understood the reason behind the blue sky. It's because of the gases present in the atmosphere. Those gases are smaller particles, and those smaller particles are scattering the light. That's why we see sky. There's one last question we need to answer. Why does the sun appear reddish during sunset and yellow otherwise? We will see that in our next lesson. Thanks for watching. This is Girish, your science activity teacher, signing off. Stay safe, take care, learn and have fun. Bye.